Open your book to page 4. Today's lesson is just some of the introduction to definitions and things like that. Okay. Actually, let's go back to page 2. So let's do page 2. So first definition is set. So on page 2, the definition of set. A set is a collection of objects or things. So for example, like over here, I have a set of highlighter. Okay. So a set is just a bunch of things. So some of you have set of toys, like figurines or whatever. Okay. Or some of you collect baseball cards, so you have a set of baseball cards, right? Some of you collect, all sort of different things. So again, a set is just a collection of things. Now let's look at an example of sets. So example 1, a 48-piece set of dishes. So that's example. Go to C, the letter A, B, C, D, E, F, and G. Right? So that's a set of letters. Now let's go to the next definition. The elements of a set. The element of a set is an object of the set. So like this one, again, go back to this example of here. I have a set of highlighter, right? Now each of these is an element. So this set has 4 elements, right? Because you have 4 of them, right? So this is one element. This is the next one. This is the next one. So each of these is an element. An element is an object inside the set. So this is a set of highlighters, and this one has 4 elements. Okay, so there are 4. 1, 2, 3, 4, right? So again, element is object inside the set. The next one is the roster notation. So when you write the sets, you always use capital letter. So you can have an A equal to highlighters, right? I think it's supposed to be this way, I think. Okay? So highlighter, right? Now, so this notation is a descriptive notation. So this is describe. Now the roster notation means you have to list every single one of them. So in this case I have the blue. Then I have the pink. I have the yellow, highlighter, right? And then I have the green, right? So I have the blue highlighter, pink highlighter, yellow highlighter, green highlighter, right? So this is called a roster notation. Roster notation means you list every single one of them. Whereas this is called a descriptive notation. You just give a description. Okay? So you can do either one, depends on the problem. Sometimes it will ask you to list every one of them. If it doesn't say, then you can do whichever is easier. Okay, let's go to, so example 2 is an example of that. Okay, example of the roster notation. Notice it lists everything, right? Okay, now let's go to the meaning of the equal sign below the example 2. Everyone know what equal sign means, right? Equal means, so this is the equal sign. So what it's saying is that the value on the left side and the value on the right side are the same. For example, you got 1 plus 1 equal to 2, right? So the value on this side and this side, they are the same. They have the same value. So that's what equal means. Equal means have the same value. Okay, we cover naming a set. Naming a set, you always use capital letter. Okay, the next definition, natural numbers. The symbol for natural number is n. So n is equal to, it's a set of natural number is start with 1, 2, 3, 4, 5, and the dot means goes on forever. Now this is called a natural number because it's what comes naturally. So when you think back when you start to when you're very young, when you learn about how to count numbers, right? again, you start with, use your fingers, you go 1, 2, 3, right? You start with 1. So that's what comes naturally. So that's why it's called natural numbers, okay? Now let's go to page 3. The next definition is the number line. Well, it's called a number line because it's a line with numbers. That's why it's called a number line. And you can start with any number, depends on what you need. You can start with, 55, 56. You can start with any number. Okay, depends on the problem. You don't always have to start with 0. Sometimes students get stuck on always start at 0 over here, and then you end up the numbers have to make it really long. Okay, so don't do that. You don't waste time, because when you do that, sometimes what happens if the number is like 1,000,000 and you start with 0, it's going to take a long time to get to 1,000,000, right? So it depends on the problem. You can start with any number, okay, but make sure they're evenly spaced and make sure they are, they have the same differential, right? So if you go by ones, each one should go by ones. So don't do this. Don't go like 1, 5, like 6, 11. That would be bad, okay? So that's no. Okay? You have to have the same increment. If you go by ones, then all of them have to be 1. If they go by 5, everyone have to go by 5. Okay? So don't do that. That's bad. Okay, so graph a number. So let's go to definition, how to graph a number. So page 3. To graph a number, all you have to do is just put a dot, and that's it. So let's say if you have 5, 6, 7, 8, and you want to graph x equal to 7. Okay, graph x equal to 7. You just put a dot on the 7, and that's how you graph that. Okay, the next one, the whole number. The symbol for whole number is W. Okay, and this way, the whole number is what you use for, like arithmetic. When you have to add or subtract or multiply or divide, right? So you need to have one more number. You need to have a 0. So notice the difference between that and a natural number. Okay, natural number is when you're counting. So you start with 1. The whole number is when you have to use it to do arithmetic. Okay. And so, for example, if you have like a 1 minus 1, what does it equal to? 0, right? So you need to have a 0 in case that, right? Because if you only have natural number, then you don't have 0, then you can't, right? So again, this is for counting, and this is for doing arithmetic. Okay, next one is digits. Okay, on bottom of page 3. Now, a lot of people get confused between digits and numbers. Digits are like alphabets. So digits, you get 0, 1, 2, 3, all the way up to 9. That's it. Okay, so those are digits. The numbers are made out of digits. So this is just like alphabets, right? You got A, B, C, all the way up to Z, right? So again, digits and alphabets, they are same type, right? Similar, right? Okay. Now, numbers are like words. Okay? So, for example, so let's say if I have an example of like 5. Okay, is 5 a digit or a number? The answer is both. 5 can be a digit, can be a number. Just like when you have this, is this a word or it's an alphabet? Both, right? Okay. But what happens when you have like 15? Is this a digit or number? Number, right? This is a number 15 made out of 2 digits. Just like when you have this word at made out of 2 alphabet, right? So any questions on difference between digits and numbers? Again, digits are just like alphabets. Numbers are like words. So numbers are made out of digits. Words are made out of alphabets. Okay? And sometimes, you can have a number that is also a digit, just like when you have a letter is also, a word is also an alphabet, right? But this is a word. This is a word, but it's also an alphabet. This is a number. This is a number, but it's also a digit. Okay? Okay. Next, let's go to page 4. So page 4, the fraction. A fraction means you have a number divided by another number. Example of that would be like 2/3. So this is example of fraction. And the top, this is the numerator, and this is the denominator. So the top is called a numerator, and the bottom is called a denominator. Okay. And let's go to the next definition, mixed number. Okay, mixed number, example that would be like 2 3/5. Okay, so this would be example of a mixed number. Now in algebra, you don't use mixed number that much. Most of the time you want to stay away from mixed numbers. Okay, you want to use improper fractions. So in this case, most of the time you would make into 13/5. Okay, so this is more useful in algebra. Okay, next one, let's go to decimal fraction. Decimal fraction is a special fraction that has denominator as a power of 10. Okay, so for example, like 4/10. And the reason this is called a decimal fraction is because this is a special fraction that you can convert to decimal by just looking at. So this will equal to 0.4. Okay? Whereas what happens if you have like 1/7? You know, how are you going to convert into decimal? Cannot, right? I mean, it's not obvious, right? So this is not a decimal fraction. Again, decimal fraction, the denominator has to be power of 10. So that way, when you look, you can know, know what the decimal is. So another example, B. If you have 5/100, so this would be 0.05. Now notice there are 2 zeros over here, so therefore you have 2 decimal places, right? You have 1 0, so you got 1 decimal place, right? So if you go to C, you got 6/1000. There are 3 zeros, so there will be 3 decimal places, so it will be 0.006, right? So again, these are called decimal fractions because you can look, you can make into, decimal right away by just moving the decimal place. Okay, if you go to D, you got 23/10. So this have 1 0 in the denominator, so there would be 1 decimal place. So it would be 2.3. Okay. Let's go to page 5, example 7. Decimal places, so A, so 75.14. This one has 2 decimal places because you got 2 digits after the decimal point, right? So B, 1.086. So this one has 3 decimal places. Okay, these are 3 decimal places. C, 25. This one has no decimal place. Okay, no decimal places. So let's go to D. You got 2.5000. Now, later on, when you take chemistry, you're going to learn about the reason for zeros over here. Okay, this is going to become important later on in chemistry class. Okay, and so this one has 4 decimal places. Okay, now when you're taking chemistry, this has to do with amount of accuracy. So 2.5000 is not equal to 2.5. Okay, in chemistry. Okay, this has more accuracy than these. Okay, so this has to do with significant digits, have to do with accuracy. Okay, so these are not equal in chemistry, so you have to be careful with that. Okay. Okay, let's go to next part, next definition, real number. The symbol for real number is a cursive capital R. So this is a symbol for real number, a capital cursive R. The real numbers is anything that you work with. You can do it on a calculator. That will not give you an error. Okay, so if you can enter on a calculator without getting an error, then it's a real number. Okay, if you try to enter something like square root of -1, it will give you an error. So this is not a real number. when you get to Algebra 2, you're going to learn that this is called imaginary number. Okay? But right now, so real number is anything you can enter into calculator without give an error message. Okay, now let's go into inequalities. So example 8. So 5 greater than 2. So when you read, you read from left to right, unless you're Chinese, okay? Then you read from right to left vertically. But all of you are American, you're over here, so you read from left to right. So you read 5 is greater than 2. Okay, so this means it's greater than. And example 9. The way to read this is 2 is less than 5. Okay, so you have to learn how to read these. Okay, now let's go to example 11 on page 6. So you need to know how to read math. So A. So this means equal to. This means not equal to. Okay. So this is equal to, this is not equal to. B. This means it's less than. This means it's not less than. Okay. Let's go to C. This means greater than. This means it's not greater than. Okay. And D. 4. So the way to read this is 4 is not equal to 5. Okay. E. The way to read this is 3 is not less than 2. Okay. F. 5. So for example F, 5 is not greater than 6. So again, the slash through means not. It's not. So 5 is not greater than 6. Okay, so let's go ahead and do some practice. So the assignment would be